Chapter 1, Lesson 10, we're looking at adding and subtracting radicals. Our aim for this lesson is to simplify radical expressions using addition and subtraction. So please copy this aim down into your notes. Make sure that it is at the top. I want you to consider this. Why can we not subtract one of these, but we can subtract the other? So you can pause the video here, give it some thought. All right, so looking at these two examples here, we see that one of these expressions, particularly this one on the left, has two different radicands. Radicands are the number under the radical sign. We talked about that yesterday. Whereas this expression here, they have the same radicand. So we can actually subtract these, and it will be pretty simple for us. So let's do this one first on the right side. We can really think of this almost like negative 3x minus 4x, which would be negative 7x. Of course, that's not our answer, but we could think of it that way. The radical 17 is the same in both, and so we can combine them through subtraction. So we can get negative 7 radical 17. So negative 7 radical 17 will be our answer. Whereas for this example, 2 radical 6 minus 2 radical 24, we would need to simplify the radicals. They need to end up being the same thing. So what we can look for here is, well, how can we get the radicands to be the same? Well, 6, if we look at the factor pairs of 6, it's 1 times 6 and 2 times 3. So neither of those give us perfect squares, but 24, 1 times 24, 2 times 12, 3 times 8, and 4 times 6. If we look at 4 times 6, 4 is a perfect square, and it leaves us with a 6. So we can rewrite this as 2 radical 6 minus 2 radical 4 times 6. Now, of course, we learned yesterday that we could take the 4 times 6, the square root of 4 times the square root of 6, with a 2 at the beginning. The square root of 4 is just 2, so we could rewrite this as 2 times the square root of 6, and of course 2 radical 6 at the beginning stays the same. So this original expression up here, 2 radical 6 minus 2 radical 24, has now turned into 2 radical 6 minus 4 radical 6. 2 minus 4 would be negative 2 radical 6. And that's going to be our difference here. So let's look at a different example. So what are the steps? Well, let's look at the 3 steps here. So the first step we want to look for is, can they be combined? Right? We just want to ask ourselves, can these be combined? So negative radical 12 plus 3 radical 3. Well, the answer should be no, and the reason is because they have different radicands. So how can we make them compatible? Well, 3, the only factor pairs of 3 are 1 times 3, so that's kind of out. But 12, we could use 1 times 12, 2 times 6, 3 times 4. 4 is a perfect square. We see that again, so number 4. And 3 would give us the 3 that we need. So we could rewrite negative radical 12 plus 3 radical 3. We could rewrite this as negative radical 4 times 3 plus 3 radical 3. The square root of 4, so radical 4 would be 2. So we could write this as negative 2 radical 3 plus 3 radical 3. And negative 2 plus 3 is equal to 1. So is equal to 1 radical 3, which is just square root of 3. So what is the result when they combine? Well, that would be our answer here. So that's the square root of 3. Okay, so let's look at a different example here. Using the same idea, if you'd like to pause the video here and give this a try yourself, you can always come back to the video by unpausing. So I'll give you an opportunity to do that now. So let's go over this. 2 radical 6 plus 3 radical 54. Well, 6 doesn't have any perfect square factors, so it's probably not going to be the 6, but the 54 does. And we really want it to actually involve a 6. So if we think about the factor pairs of 54 that involve 6, we could have 9 times 6, which is 54. So we could rewrite this as 2 radical 6 plus 3 times the square root of 9 times 6. So if we look at our steps, can they be combined? Not the way that they were, so the answer is no. How can we make them compatible? Using this step here. So I'm going to rewrite this here, 2 radical 6 plus 3 times the square root of 9 times 6. The square root of 9 is 3, so this will be 2 radical 6 plus 3 times radical 6. So now this is 2 radical 6 plus 9 radical 6. And what is the result when they do combine? Well, 2 plus 9 is 11 radical 6. So that should be our final result. If we look at an example such as this, negative 9 radical 15 plus 10 radical 15, can these be combined? Yes, they can, because they already have the same radicand. So when we're looking at the adding and subtracting for radicals, we want to think of this almost like the rules for fractions, right? When we talk about adding and subtracting fractions, we always think that the only way to add a fraction like 1/2 plus 1/3 is if the denominators are the same. So we make them the same. We say this is 3 over 6 plus 2 over 6, which is 5 over 6. And so the phrase that I want you to think of, if they have to be the same, they both have to be 6. When we actually add them together, it has to also stay the same. So if they have to be the same, then they have to stay the same. And that's very important for fractions, and it's also very important for radicals. These had to be the same for them to be possible to add, so now they have to stay the same. So negative 9 plus 10 would be 1, so this is 1 radical 15, which is just the square root of 15.